Hey developers! In a recent video I introduced you to the Arduino PLC IDE, which has recently been released by Arduino. That was just a quick introduction to the platform, but when I created that video I promised that I would make more videos about the platform, so here we are. Today I thought we would make these two chaps talk to each other. So this is the Arduino Portenta machine control, and this is a Beckhoff PLC. Hello. Hi. So the Arduino Portenta, that's the only controller that is supported by the Arduino PLC runtime as of today, though Arduino are soon releasing the Arduino Opta PLC. As we saw in the last video, the only industrial Ethernet-based protocol that the Arduino can talk, at least right now, is Modbus TCP. So I think that is an appropriate communication protocol for the PLCs to talk to each other. In this video, I will be setting up these two PLCs so that they will talk to each other over Modbus TCP, one acting as a Modbus TCP server and the other as a Modbus TCP client. Without further ado, let's get started. Hello everyone, so it's time again for a little bit of programming. What I've set up here is the Arduino Portenta machine control board, and I've hooked it up to a Beckhoff CX PLC running TwinCAT 3. And my idea here is that I want to make these two guys talk to each other using Modbus TCP. The way I thought about it is to make the Arduino board to be a Modbus client and connect into a TwinCAT server. And what I want to do is to read data from the server using the Arduino, and I want to write data to the server as well. So this is the goal for today, to make these two PLCs talk to each other. I have created a completely fresh project here, so this is just completely fresh. I called it Modbus TCP test project. I haven't done any changes other than making sure that I can connect to the device. Secondly, I have a TwinCAT project running here on the PLC, and I've just followed the manual from Beckhoff regarding how I can put up some Modbus registers so that they're exposed in the server so that the client can reach them. So I simply did exactly what Beckhoff suggested here by creating 4 arrays in a global variable list, which is what we have here. So hopefully by exposing these 4 global variable arrays, the client should be able to connect to this. Basically, we're not going to do any more software development on the TwinCAT side other than running this. So this project is running on the PLC right now. And the nice thing here is that we have an online view, so we can easily see and change the registers of the Modbus server. If you want to see how you work with Modbus on a TwinCAT PLC, I've already done an episode about that. I will put a link up there or there somewhere so that you can watch that episode as well. When I started this, I already noticed that there are some function blocks for reading registers and writing them. There isn't unfortunately anything in the documentation regarding how to use Modbus. There's no examples. I looked everywhere. They have one example for Modbus TCP, but it's very basic and it doesn't go into the details that I think we need to get this up and running. What I didn't mention in the last introduction is that there is a very good help document here. So if you go to help and about, no, not help about, sorry. If you go to help and index, then you have a PDF here that is really, really good. So I should give credit to Arduino for that. I'd really recommend you to look through this. There's lots of stuff. Unfortunately, again, nothing about Modbus, unfortunately. I'm expecting them to update much more documentation for this product and for this IDE in the future. When we looked at this the last time, we noticed that there was some stuff with hardware here, so I thought let's start in this end. As Modbus TCP is based on Ethernet, we can already see that we have some stuff here. yeah, the problem here is now they talk about Modbus TCP master and Modbus TCP slave, while the Beckhoff documentation talks about a Modbus TCP server and a Modbus TCP client. So this is a little confusing for me. I don't know, is a server a master or a slave or the other way around? It would be nice if there was some consistency here. I'm not gonna dig at this right now. I'm just simply gonna try to read something using these function blocks and see where we end up. So if we go to our program, we have our main program. We can just instantiate an instance of this function block. Where is it? Here? This read Modbus register using read input register Modbus command. That sounds like there is something we want to do. Another thing you can do when you declare the variables is that you don't have to use this graphical user interface for the variables. You can switch over to here, and then it looks more or less like TwinCAT. So, well, actually for TwinCAT, I think you can do it graphically as well, though I'm not used to that. I prefer to do it by text. So let's run this directly in the main program. So this fast cycle, and make an instance of it. So let's call it fd modbus read register, and that's a sys mbmt. I wonder whether there's an easy way to just copy this. Okay, no, I can't. Why not? Yeah, that's a little annoying. Let's keep that counter, but let's move the counter to a local variable. I don't like global variables, as everyone that knows me knows. Let's get rid of the whole global variable list. So let's get rid of the variable, and then let's call it. Okay, so we have some inputs and outputs. We can maybe look at that. So what it needs is the index of the node in the network, whatever that is. Okay, so it's not an address, an IP address or anything. Actually, regarding IP addresses, where do I set the IP address of the device? Then it needs the register to read. Okay, so this we know, it's gonna be these guys. Then it needs a data type, so this we also know, and a timeout. And then it's providing some outputs on status and the actual information we're gonna read. Interestingly enough, we don't have any busy or we don't have any busy flag, basically. So I'm assuming that the call of this function block happens synchronously, which isn't very comfortable. Then I don't like the concept of running it in a main task or a fast task, because then we have no idea how long it's gonna take. If it runs synchronously, I mean, the device can take 10 milliseconds to respond, but it might as well take 5 seconds to respond. Yeah, let's just make sure this works first, and then we can discuss this. So node is no idea. It's probably some number for something. The registry address is, let's create an int, so we can change this online and see what happens. And then we need a data type. That's let's just create an registry data type, which is a sys mbmtcp type D. And what is this? Okay, yeah, so we want to read a word. So hopefully you can copy this. Actually, let's change that online as well. So we don't set anything here, but we change it while we're logged in to the PLC. Timeout is a timeout in milliseconds. So this we can. TMO is, I don't know, 5,000 milliseconds. And the outputs we can hopefully read when we look at the function block. So if you run this, it's not going to compile because we have the question mark here. Let's see if we compile. I'm used to pressing Ctrl-Shift-B from TwinCAT to do a build. Okay, an error, not a big surprise. This is the error. The question is, what do we put in this node? Let's look at resources. You know, let's just put a 0 here, or a 1. Run this and see what happens. This we can always do. That's the wonders of software, that you can easily change it. I prepared a normal ID here because I like the normal ID when I want to do some serial monitoring to see what the device is doing, because normally the Arduino runtime is just throwing out lots of stuff over the serial connection, so you can see a little bit of what it's doing. I'm expecting that we're probably gonna have to use that soon. Okay, and let's upload it to the PLC. Yeah, I guess it's running, so let's just put this counter to watch. Why can't I put it to watch? Because I haven't gone online, that's the reason. Okay, maybe now. Oh, that looks good. Let's do the same thing with this guy, the whole function block. Oh, and here we... Okay, so we got an output, operation result. TCP not allowed in timed task. TCP not allowed in timed task. What does that mean? Well, it obviously means not allowed in timed task. But what does not allowed in timed task mean? Does it mean that we can't write any code running in any task, but that this is only some sort of no-code solution that Arduino wants, so that they want you to, let's go offline, that they want you to use this, or yeah, I'm really confused here. Do I have to, or do I mean, I'm not very fond of these no-code, low-code solutions. If I want to write my function blocks and use them, then I should be allowed to do it. But it says not allowed in timed task. I mean, all of these are timed, right? So if you look at them, well, we have the init, but that doesn't make any sense because that only happens once. I want to do it all the time. You know what I'm gonna do? I'm gonna try to move this main program to the background task instead. Can I do that easily? Can I move it? No. Yeah, okay, then I'll just create a program and call it... Oh, I have to create a program first. But I want to... Oh, I can do like this, okay. But then I don't want it to be executed in the fast task. So, yeah, wait, I don't want it to be run in slow task, I want it to be run in background task. That's what I wanted to do. I'm just guessing here. No, let's clean this guy up, let's compile it. Let's connect and download the program. Let's put these guys to watch again. Let's just do a clean restart. So let's do a reboot. It's obvious that I'm new in this ID. I'm not 100% comfortable here yet with stuff, but yeah, we can actually see that it's running in the background task, because the background task was just running every 500 millisecond instead of every 10 milliseconds, so it should run twice a second. And now let's add this to watch. Oh, okay, so it's still an error, but it's a different error, and for me that's a success. If I have another error than I just had, it means something has changed, and that's progress. So we get minus 300. What's that? Again, how do we look at that? The output is... How do I find out what type this is? It's minus 300. What does minus 300 mean? Let's look at the function block again. The output is sys mbm tcp esi. Maybe it's here. Yeah. So what is minus 300? Minus 300 doesn't exist. Okay, Arduino, that's not helping me. What does minus 300 mean? Can you tell me? Because I don't have any magical powers to guess what it means. I know it's probably something bad. Actually, maybe it's that I'm trying to... it's because I'm trying to read a registry that doesn't exist. So let's read something. So 8000 was the first one, right? 8000, yeah. In hexadecimal, and that's 32,768. 768. Ah, yeah, wait, we have to write to this because it's overwritten, of course. Why can't I add this to watch? Do I have to print it here? Yeah, okay, weird. 32,768. Still the same problem. Maybe I need to change the data type. to a word, because that is what I want to read. No difference. Okay, what I'm gonna do is I'm gonna reboot the board and see if I get anything in the serial monitor plotter. So if I just try first to disconnect, let's use tools and see serial monitor. So if I close this one, I connect and I reboot it. Maybe I wasn't quick enough, or maybe I'm watching the wrong thing. Let's try again. Let's reboot the target. Look here. Now we get messages on the serial monitor. Networks, maybe this is the problem. Network started with DHCP. Modbus master TCP IP no valid configuration found. Yeah, I mean, if you think about it, we haven't set any IP address of the device. That can't be a good thing, especially if it's expecting DHCP. I mean, this device is completely disconnected from. It's only connected to the PLC, so there's no DHCP server, and the address is static on the DHCP end. So let's try to set that. Let's figure out where we do that. There's nowhere here where I can set an IP address of this guy. Look here. Configure static IP address. That sounds good. Okay, so the PLC is 192.168.1.1, so this can be 1.2. Yeah, we can leave all of this. I guess it doesn't matter. Which is interesting. I just realized maybe this means that we can run a sketch at the same time as we're running the PLC software, which would be awesome. Although of course, in the back of my head, I'm thinking, where is this running in relative to the other tasks? But it's not interesting for now. Now we just want to solve the problem of setting an IP address. So we have to focus. Focus. Of course. I'm so stupid. And compilation. It actually even says here, enable usage of ET class to set static IP address and other, which is what we want. So let's put this on the PLC. Still minus 300. Let's check the serial plotting. Okay, progress. Network already connected with IP address. So now it's actually using this IP address. That's good. Waiting TCP IP connections on port 502. Yeah, actually, you know what? I just realized another thing. We haven't told the Modbus TCP client here. We haven't told this guy where to connect to. So we haven't told that it should connect to 192.168.1.1. I'm assuming node 1 here refers to something that has all the information it needs. I mean, it's not just the IP address, it's also the port. It should be, default port 502 for the Modbus server, but I don't know, maybe it's want to use something else, and in any way I should be able to change it, because maybe what if I'm using port 502 for something else and I want to use port 777, for example. So I'm assuming there is some configuration work here left to be done, and we have to find it. So maybe you need to add something here, a generic Modbus. Let's do that. Okay, so generic Modbus node. That might be it, right? Let's just... minimum polling time. Why do I set it here? Isn't that defined by the task? And what's this? Yeah, I don't want to do this. I mean, this is okay, so now I'm just assuming that this is something that you use if you don't want to write any PLC code. So you have this no code, low code thing. I saw it somewhere in the commercial material for the Arduino PLC IDE. I'm not a big fan of no code, low code stuff, because usually it ends up with lots of code. So let's remove this. Maybe it's enough that we add this, and then this one somehow it's automatically gonna get node ID 1. I don't know, I'm guessing. And again, there's no documentation for this right now, so I'm just guessing. And I think my guess is probably as good as anything we will get right now. Let's run it again. Maybe it's the index of the node in the network. And I mean, this can't be the port number, and it can't be the IP address either. And thinking about it, we only set the IP address here. We didn't set any port. So yeah, this is confusing. Let's just download it. Okay, still minus 300. Maybe that's because we have to change this, the address, 32,768. Oh, sorry, this guy. We have to change this. No. I have a feeling this is gonna take a while for me to figure out. Okay, everyone. I spent a little bit too much time on this, but eventually the only thing I did was that I restarted the PLC. So basically I Control-Alt-Delete on the Arduino PLC, I should mention. And when I did that, then look what happened. Yeah, network connected and everything. And then when we go further down, Modbus blah blah blah, Modbus blah 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 blah. Here, open connection with slave 1. So IP 192 blah blah blah. This is the PLC. Do you remember? We set the IP address 192.168.1.1 there, and that apparently automatically means that it will be node number 1. And then I assume if you add another one, it would be node number 2. So that's the connection between the IP address and everything. And then it says slave 1 running. So it is connected to slave 1. And now if I close this one down and I go back here and I go online, I get MB TCP OK. And this is so the return code 0. So fine. So it seems to be working. Now we will continue with changing the registry address. So we want to go to registry I don't know, 8000. I always confuse if it should be the input or output registers, but it's anyway the same address. So 8000 is 32,768. Let's do that and let's read a word. So we get a 0, and now the moment of truth. If I change one of them or both, I don't know which one. Let's set, if we set a number here at that address, I just changed both, then we should see result data word. D word is 0, nothing. So we still get 0. I mean, just from my experience when doing Modbus TCP, getting these addresses right is never easy. So let's just try. I mean, maybe this is in hexadecimal. I doubt it because it's an unsigned integer. So it, yeah, let's set it. Oh, sorry, wrong place. Let's set it to 8000. No difference. 8001. Okay, let's set it to 32,769. Well, let's set it to 0. No. Okay, so let's set it to 1 above 32,768. We got something. We have this nice format thing I discovered. We can do unsigned. 123. Yep. So let's just figure out which one it is that it's reading. Is it this one? Let's set it to 456. No, then it's probably the other one. 456. Yeah, there we go. Okay, so through some magic, we managed to get the Arduino to read data from the Beckhoff PLC. Let's have a little bit more fun and write to the PLC. So we're gonna use another function block. So let's disconnect and use not this one, but the write register. So let's Modbus write register, then it should just be write reg. Okay, there's two variants, M and S. What's the difference? Multiple registers versus single. Okay, so we just want to do a single, and it should therefore be write reg S. And let's do a write. And what does this guy want? Did I do something wrong? Modbus did write reg. No, it looks good. Right? Can I compile this? Yeah, it works. So it wants the node. This is 1. Through some pain, we managed to learn that. Reg adder. You should never give up. That's what I have learned. We can point to the same variable as we used before. Should never give up because computers are nice. In the end of the day, they will hug you and say, you are a kind person. Of course, I will do what you want me to do. Data type is, yeah, so that's a word again. We can actually set that. We can set that, yeah, we can do it the same way as when we read it. Data raw, data to be written. Okay, so let's put some n data to be written, a D word, it wants a D word. Then we can change this on the fly. And see that it's written to the PLC. And then timeout of 5000 as well, because that seemed to be working fine. And the output we can just see when we're online. Is there anything else? No, I think that should be everything. And then we don't do any read, of course. So let's compile it and download code. Let's just clean this guy up. Let's put this back so we can do one watch, watch, and watch. I pressed F8, by the way, because that's what it's, I saw it's here somewhere. Yeah, at watch is F8. Now we have, yeah, we have an error, of course, because we're pointing to, probably because we're pointing to somewhere that it can't write to. Let's try change the data type first to, I don't know what it should be, a word. And the data to be written, we need to add to watch as well. Let's just put something here, not in hexadecimal, because I get very confused. So just 678 or 7678. There we go, data raw changed, and then the address is probably, now let's write to the same position as we read from before. Doesn't seem to be working. We have this annoying thing. Ah, wait. I of course have to change the address here, because I'm using this registry address as an input to the reg address. And what basically happens, if this is 0 and I change this one, then it's gonna be overwritten, right? Because if, yeah, so I have to change this one to 32,769. I still get minus 300. Why? Computers, why don't you ever wanna be nice to me? Okay, again, I just did a reboot and then it worked. And I mean, when I say reboot, I didn't pull the plug and power in, connect the power or anything. I just simply went here, reboot target. Then it was okay. So maybe it has to do with the online change somehow didn't work properly. I have no idea. But I reboot and it works, so I'm fine with that. So let's again change with the data type to Word. Registry address, data to be written. Let's write 1, 2, 3, 4, 5. And we want to write to the address of 32,769. We still get an okay, so let's see on the PLC. But maybe it's the output. Yeah, look. So we read from the input registers and we wrote to the output registers. Let's just double check. Data to be written. Let's write 999. 999. Amazing. It works. So we have managed to read from the PLC. We have managed to read data from the Beckhoff PLC to the Arduino PLC, and we managed to write data from the Arduino into the Beckhoff PLC. So two-way communication. Yeah, I hope you enjoyed this. It's been quite fun to do this. I, of course, expect Arduino to update the documentation so it shows how to do this. Because I'm expecting Modbus TCP to be quite a common use case amongst the users of the Arduino PLC environment. I'm of course hoping that Arduino will add other field buses as well here. Maybe they will add an TwinCAT master stack. Maybe they will add Profinet. I mean, there's many other industrial networking protocols, and it would of course be nice if they added it, considering how many different IO blocks and stuff there are with these protocols. I mean, there are IOs with Modbus TCP, though it's quite limited compared to the more popular fieldbus protocols. Anyway, that was what I wanted to show you today, so thank you very much and see you soon.